Hello, everyone. Welcome to Wind Down Friday. Today, our special guest is Matthew Lumb, the founder of and CEO of Polaris Semiconductor. Hi, Matthew. Welcome aboard. How's it going?
Hi, yeah, thanks very much for the invitation. Delighted to be here.
Absolutely. Thank you. Thank you for coming on. So, Matthew, welcome to Wind Down Friday. I have a couple of questions to share with you. We would like to know more about you. You gained a PhD in physics in the field of semiconductor quantum dots from Imperial College London, and then you have also a great career in terms of companies, research, academic, and so on. So let's start with the big leap. What inspired you to transition from deep research and academia into founding Polaris Semiconductor? So was there a particular moment or challenge that pushed you to take this path, this road?
Yeah, I think there are several factors that have contributed over the years. So right out of my PhD, I worked for a company in London called Quantisol. So it was a startup company developing multi-junction solar cells. And that really it was a really terrific experience and working with a great team of engineers. And I was there for almost 2 years, and I always knew that it was something I'd really like to do again. You know, that idea of building something from scratch was really enjoyable. And then I came to the US in 2011, worked at the George Washington University and as a contractor at the Naval Research Lab. And it was really while I was there that Polaris began. So it started as a patent. I had this idea for taking a linear regulator and including this photonic technology that gives it very unusual properties. But one of the great things about George Washington University is they have a very good technology commercialization office. So the TCO at GW, they helped me with the patent process, and they also entered me into their pitch competition, which anyone who's filed for a patent that year was eligible to pitch to some investors. And so it was the first time I developed a pitch deck for the technology, and I ended up winning. And so there was a cash prize, and it was the first time I really thought that maybe there is something more than just academic curiosity in what I built, and got some good feedback from that. And that was really the moment that set me in motion. But then one of the great things about the US is they have a really big, non-dilutive kind of funding ecosystem called SBIR, Small Business Innovation Research. And so they really specialize in funding technologies that are very early stage, probably too risky for an investor to get meaningfully involved with. Yet they provide enough resources to build some hard tech demonstration. And so I applied for an SBIR grant and was successful from the National Science Foundation. So at that point, I went part-time. And I've never really looked back from there. It soon after another project came along, and so I went full-time. And then almost 2 years ago, hired Ken Schmieder, who's the CTO, and he's a really outstanding technologist and has really helped drive the technology forward, and been great to work with. And that's where we are today. We're still in a relatively early stage, but we're still growing, and the technology is now at a much more mature level.
Good. And for our community, so we have posted an article about Polaris on powerelectronicsnews.com. So in the abstract of this video, you can find the link. So please click and read this article. So in terms of another question, Matthew, business lesson. So is there some unexpected business lesson? What's been the most unexpected business lesson you have learned since founding this company, Polaris?
Yeah, great question. I think, being being a researcher by background, I've learned a lot of lessons, because I'd worked for a company but never tried to set one up and run one. I'd say the one thing that really stands out is the value of building something that uses existing technologies as much as possible. Because really, as a scientist, you're very focused on innovation and making things as new and innovative as possible. But it's not necessarily a good thing for adoption in the real world. And so for engineers who are using incumbent power management technologies, the fact that you can make something that resembles the incumbents in many ways actually makes adoption into systems easier. And also, early on, because part of our technology is a linear regulator, I was thinking we'd be needing to design and develop a custom linear regulator that really fit the specific specifications were required. But once I went out and actually talked to people who could be potential customers one day, I realized that using a well-known linear regulator part that's already in existence gives customers reassurance. And, for example, one of our lowest noise part uses a linear technologies chip, now analog devices, called LT3045. And as far as LDOs go, this chip is a work of art. I think it's a very, very good design of chip, but it's also very well known in RF communities as being kind of a very low noise chip. And so when you can mention that our technology, that's at the heart of the technology, that gives a lot of kind of unexpected credence to your technology that I hadn't really thought that would be the case at the beginning. And also, our optoelectronic technology, our optocoupler devices, these are a very unusual device, but very intentionally, we've built them on technologies that are essentially the same thing you'd use to make a gallium arsenide LED. And so there are no special materials, there are no special processes. It's very standard manufacturing process. And that's a very kind of intentional decision. We could make that chip basically at any gallium arsenide-based foundry and processing fab anywhere.
So let's nerd out for a moment. Your work moves from spans in quantum dots, 3D materials, optocouplers, now in LDOs. So all topics very close to my heart. So how do your roots in quantum semiconductor physics influence the approach to device level innovation today with your company?
Yeah, I think the common thread is that pretty much everything I've worked on in my career has been focused on, in one way or another, conversion of light to electron hole pairs and back again as efficiently as possible. And, it's how if you make that process very efficient, how can you utilize that in a device to improve the device performance? So, in quantum dots, it was laser technologies. Then I worked in a lot of photovoltaics where, it's that conversion, quantum efficiency conversion is obviously extremely important. Photodetectors, and then now optocouplers. And so there are a lot of like commonalities in them. I would say that when I started working on a voltage regulator, this was definitely a departure from the kind of devices I'd used in the past. And, certainly a lot of coworkers were kind of a little confused when I said I was going to start a power management technology company, really. But once you scratch below the surface of what we're building at Polaris, you realize that, yeah, it's that same idea of basically converting electricity into light very efficiently that is really the enabling technology for what we've built. And a lot of my prior experience has been in simulation, in modeling. And so, when I was working at the Naval Research Lab, I was developing a lot of modeling tools. And so once the patent had been filed for this technology, I spent quite a bit of time developing a device model for the optocoupler, and um, so it was an area I was very familiar with and had a very good basis from my prior work, and it was consistently showing that this optocoupler device, where we've eliminated a lot of the losses with traditional optocouplers, should be more than 50% efficient. And that's a very high efficiency for an optocoupler. That's electrical power out of the PV to electrical power into the LED. But I must say, when we finally got funding and we built the first prototype, I was pretty nervous that if I have a factor of 2 in my code and I'm double counting the LED photons or something, then we could be way off. And that was a kind of a nagging concern in my mind. But thankfully, when the prototypes arrived, they were very close to the model, and we haven't really changed that first design very much. There have been improvements and optimizations, but the core idea is as it was five years ago now.
So let's walk the wavelength of Wind Down Friday. So stepping away from technology, from lab. So what's your favorite way to disconnect, to recharge your battery after a day of deep problem solving, probably? So hobbies, any hobbies, routines, off the grid escapes?
Well, I have 2 young kids. I have a 9-year-old and an almost 6-year-old, 2 daughters. So combining that with my job, I have very little free time. They have great social lives and do a lot of activities, and I find myself, chauffeuring and attending ballet lessons and things like this. But there are a couple of things I've been working on more as a hobby. One is that I'm learning Spanish. I have been for a few
Nice.
years. I'm lucky to have a beautiful wife from Spain, and so my children speak Spanish and English, and so
Good.
I've definitely been. I'm still not quite at my elder daughter's level, but I'm working on it. And also, it's great that I get opportunities to go and visit that wonderful part of Europe, and so that's something I do in my spare time. And the other thing that not everyone knows about me is I'm actually a violinist. And so when I was younger, I used to play in various orchestras, and we had a string quartet. I was certainly never going to be the next Joshua Bell. That was clear, but it's something that I got a huge amount of enjoyment out of growing up, and still occasionally I will dust it off and play a few tunes for the kids. So it's music has always been something I've really enjoyed.
Nice. Thank you, Matthew. So let's talk about young people, young professionals that are looking to build something of their own. So something of a company, for example, like you did, like you are doing. So what's one missing of skill? What's one underrated skill that you think they should learn, that should develop outside of technical expertise that for sure they already learned from university?
Yeah, I think obviously Polaris is still a fairly early stage company, so I'm still I'm developing skills every day. But I think the one thing that is really important and that's sometimes lacking in people who are working in research labs is the ability to communicate your ideas clearly. And so it's very hard to do. And it's something that a lot of very technical people really struggle with because, in the case of our innovation, it's a very nerdy innovation. And if you're trying to talk to someone in the street about electromagnetic interference, they're very quickly their eyes are going to glaze over. But yet you might have a technology that, even though the merits of the technology are very technical, they're real merits. And so you've got to be able to find a way to communicate those ideas to people and show them the value of what you're doing. And so that involves a lot of talking to potential customers. You have to be able to get out of your comfort zone, meet people, and also listen to what they're telling you, because no one really wants to spend all that time and effort developing a technology that ultimately no one will want. And so it's that, I think that communication aspect is really key.
Thank you. So, Matthew, last one. Finally, looking forward, looking in the next future. So, what's your vision for Polaris over the next few years? So, any directions, any markets, any challenges you are excited to explore?
Yeah, absolutely. I mean, in terms of in the near term, we're in the process of fulfilling our first ever order, which was a really big moment for us. And we're launching some chips to the International Space Station. So we got awarded a grant from the ISS National Lab. So it will be the first flight heritage for the devices. So these are things that we're working hard on. The main focus for us technically, and has been for quite some time, is quality assurance. And so, we understand the devices very well now, and they're at a mature level, but we've been putting a lot of attention on making sure that they can survive for thousands of hours in harsh environments. But in terms of next generation things we're looking at, one interesting device that we're considering developing is a device capable of generating low noise regulated negative voltages. Because right now you really have to use switching for that. But if you can use this same kind of linear idea coupled with the optocouplers, you can essentially do a very similar thing to what we're doing with positive voltages in the negative voltage domain. So you could have a positive single supply that provides, for example, split positive and negative outputs, each with very low noise. So we're very interested in that idea. But also we're planning on developing something more like a PMIC, where we'll have multiple channels that can be controllable with some kind of logic brain. And then I think in the long term, an area I'm really excited about is chipletized architectures, where the fact that we don't need an inductor and we don't have any switching in the device, yet we can achieve pretty high efficiency. I think that lends itself very well to inserting our technology directly into chiplet architectures, where we can deliver low noise power, right at the point of load, with a very kind of compact solution, and not have the usual thermal trade-off you'd have with a conventional linear regulator. So I think that's an area for us that we're definitely quite excited about possibilities there.
Thank you, Matthew. Thanks a lot. It's been super having you here at the Wind Down Friday. I wish you a great weekend, and stay in touch.
Thank you.
For sure.
Yeah, will do.
All your activities. Thank you, Matthew.
All right. Bye-bye now.